Hi, I'm Jeff, and this is Lithic Metals. Welcome back to the lab. What I have here today is approximately 1,363 grams of a 90% silver alloy that I'm going to be refining for Lauren over at Outlaw Coin Creations. I'll add a link in the description so you can get a chance to look him up, because he really creates some magnificent stuff. Well, our first step to refine something like this, let's take a look here. These are some pretty good sized half spheres. I don't know if it's just cast off from a project or what we have here, but like this one in particular is approximately 83.75 grams. So these are pretty big pieces. Our first step would be to heat these up and melt them in the furnace, pour them off, and cast them into shot. That would be ideal for our digestion process. Man, that's a tough one for me today. More surface space, more area for the chemical to attack. But what I'm thinking here, for the sake of experimentation, I'm just going to put these right into solution as they are and see how long it takes to dissolve these big babies. Some of these are really huge, you know, and it might take so long that I throw in the towel and pull them back out of solution and melt them down. We'll see. It's definitely going to lengthen the digestion process, but I think it'll be worth the experiment. Alright, so I'm going to get set up in the fume hood, and I'll see you there. Okay, we're all set up in the fume booth. I have approximately 200 mLs of nitric acid, and I have approximately 3/4 of a liter of used rinse water that I used to rinse silver crystal out in a previous silver refine. You know, every drop of fluid that I end up using here needs to be processed in the end and rendered inert, so it's not hazardous for the environment. So I'm going to recycle things as often as possible. So you may notice in the bottom you see some shiny crystal-y sparkles. That is silver. That is super fine powdered silver that ends up floating. If it stirs around, it ends up floating to the surface, and the surface tension kind of carries it into the waste process. I recover it in the end, but in this case, this is just still good distilled water with practically undetectable amounts of copper. I don't know what the other 10%, this is 90% silver alloy, I don't know what the other 10% is. I can assume it's copper and a variety of other things, but so I'm not introducing anything that's like far out or crazy. It's just used rinse water that can be used again. So it has a little bit extra silver that we'll have to digest, but that's fine. It makes up for whatever floats out in the process later on as well. So let's just get started and get this in our beaker here. I think we can just pour it all in. With approximately 1,360 grams of this alloy, without going too crazy on the math, it's pretty easy to just say that we're going to need at least 1,300 mLs of distilled water in our solution. We want a good, at least a minimum of 50-50 mix. More water's okay. But we want at least 50-50 nitric and water mix. I usually go a little heavier on the water side. Get these out of my way here quick. The problem with adding too much water is, in the end, that is more water that you're going to have to process. I don't mind going a little bit heavy on the water here because this is going to take a while and there's going to be a lot of evaporation. We're going to be adding more water. And I'll get to a point where we get a third or halfway through dissolving these pieces, and I'm going to want to dump that solution off and start fresh anyway. But and with that, we could estimate safely that we're going to need approximately 1,300 mLs of nitric acid to dissolve these as well. So I have a 4-liter beaker over here that we will be pouring our solution off into as we go. But right now, let's just heat up our solution. Put it on a medium heat. And we don't have to wait for it to get warm. Since our solution's cold, I'm not too concerned about an overwhelming vigorous reaction here. It will have an instantaneous reaction once we pour this nitric in here, but it won't be all consuming here. So we can give it a good healthy dose. Approximately 50 mLs I put in there. And let's get this capped off here. Not sure how well the camera's picking it up, but I'm already seeing some of it starting to attack. But it's going to take a little while before it really gets going. So why don't we close the fume hood, or the fume booth here. We'll turn the fan on high. You can watch it for a few minutes and then I'll cut the camera away and come back when there's a little bit more action. Well, it's been 1 hour since we began our experiment, and I think it's time to get another temperature check here, and I think we're going to push our solution a bit more and add some more nitric acid. Degrees Fahrenheit. I'm going to turn that up just a little bit, make it a little higher. notice a few of these pieces. Well, let's do that. Put the window shut. Notice a few of these pieces here have changed colors. Whereas some look like they're pretty close to 99% silver here, and others you can see there's some definite contamination. So I don't know what the difference is. I'm assuming the amount of copper, but I really don't know. So if anybody wants to take a guess or has better knowledge of that than I do, please let me know. But I think we can watch it here for a few minutes, let that acid do its thing and kick in, and then I'll turn the camera off and we'll check back with it and after either reaction builds or dwindles. Well, at this point we are at going on 5 hours into the experiment, and I am going to check the temperature. I'm going to rehydrate this fluid. Due to evaporation, we're going to lose some of our water, so I'm going to add more distilled water so the metal has a place to go in the solution. And then I will proceed with adding more nitric acid. So far we've consumed 2, 4, 5, about 550 mLs of nitric acid. We have approximately another 100 in our beaker, in our dish there. So let's get cracking. Now we're at about 160 degrees. That is going to go down considerably right now. Just added about 300 mLs of distilled water. About another 40 mLs of nitric. We'll let that heat back up and do its thing. 70. Alright, at this point we are going on 9 hours into this experiment. I've added 2, 4, 6. I've added 700 mLs of nitric acid. We've put in approximately 1.2 liters of water. Looks like we have about 1.5 liters of our solution here. So we've had some evaporation. At this point, I think I'm going to let the nitric burn itself out. I'm not going to add any more. I'm going to let the solution stall and cool, and then I'm going to siphon it off into our container on the right here. I think I've pushed this solution hard enough. There is this blue color that we're seeing. You know, if this was pure silver, this would be a crystal clear solution. This blue is a clear indicator of copper. So, but I think I've pushed it hard enough, so we'll let this just burn off, and I'll continue the heat until I don't see any reaction. I want to make sure there's no free nitrates in solution. So it's going to take another hour and a half at least to fully cook off and cool. So we'll let it do its thing some more. And when we get to a significant shift in what we're seeing here, I'll turn the camera back on and we get an update. Till then. Well, we're 10 hours and 45 minutes into this experiment, and it looks like our nitric acid is exhausted. Not much of a reaction, if any. At this point, I'm going to stir it around a little bit, but just to make sure that there's nothing weird settling anywhere. I can't imagine, but just in case. And I'm going to turn off the heat, and I'm going to let this cool. I think at this point, I'm going to call it a day. I'll let this cool overnight, and tomorrow morning we'll siphon it off into our container to the right. Alright, so let's finish this up for the night here. Set this down. I'm going to turn the heat off. I'm just going to swish this around a little bit here. that's it for the night. We'll check back on it in the morning. Just like that, it's a new day. Our solution has had overnight to settle. It's cooled down. You see it's a beautiful cobalt blue. No crazy impurities, just your average base metals. Temperatures approximately 63.5 degrees Celsius. Nope, not this one. 63 degrees Fahrenheit. If it was Celsius, we'd have a different issue going on right now. So we are ready. We're going to start fresh today, but before we do that, we need to siphon off this solution. I'm not sure if I have enough height to get a good quality vacuum going here, or siphon going, but we're going to give it a shot. So give me a second to reposition the camera and we'll check right back in. Well, we have our solution siphoned off. It looks pretty much as expected. I was kind of hoping that maybe more would be gone, but hey, this is actually better than I feared it could be. You'll notice they aren't digesting all at the same rate. This little dark one here, that was a pretty big piece. That was one of our largest pieces. And it's dissolving up pretty quickly. This little guy here is almost gone. This was a big one, and it still has a ways to go. It's going to take quite a bit to whittle down these big blobs, but we're getting there. We're getting there. We're at least probably halfway through the process. So I'm going to start. Let's add some distilled water here. I'm going to put, I added about a half a liter of water, distilled water. Get some acid prepared here. Our distilled water is pretty cold. I'm going to add probably about 50 mLs right off the start here. Oh boy. Have the heat on medium. We'll let that warm up and come to temperature. You can see we already have a reaction starting. It's like I touched it. Here too, the bubbles are already starting to come up. So, immediate reaction. Hopefully the camera's picking that up. are down to the final little pieces here, and our reaction has stalled. Pretty confident that we used up all of the free nitrates, and instead of chasing after these little pieces and adding more nitric acid into the mix, I think I'm just going to pull the pin on it at this point. I'm going to reduce the heat. I'll keep an eye on it, make sure that I don't see any traces of a reaction happening. Let's do that right now. We'll just turn the heat down. The bubbling we're seeing there is just the heat transfer from the metal. There's no fumes coming off or anything like that, and the solution is pretty hot. So we'll back that down. That bubbling will dwindle, and double check for the reaction. If I don't see anything, I'll just let it cool down completely, and at that point I will dilute the solution with more distilled water, and we can go over that when it comes to it. I'm going to pull the camera out and get a closer view here. Well, our solution is cooling down. Earlier off camera, I diluted this solution here, our earlier pour off, with about a half liter of distilled water. And I'm going to dilute this solution just a bit as well. It'll work to cool it down, and if the levels are concentrated too high, when it does get cool, I could end up getting like some silver nitrate crystals to grow, and I don't need any of that. It's soluble, it rinses out, but I'd rather avoid it. So I am going to let this cool down just a bit more, and then get set up to filter this solution. Well, I got us all set up to filter our solution. This is what we poured off yesterday, our first batch here. And this is what we were working with moments ago. I have a fresh filter in our Buckner funnel, and I think we are all set. Let's just get started then. Oh, this is always so much heavier than your brain thinks it's going to be. It's not water. Give it a little assist with our vacuum here. Instead of getting another beaker in the way, I'm going to flip a few things around here. What we're going to do is pour the remaining of this solution into today's batch. check out our filter here. Well, it definitely did the trick. And these are our few silver pieces that we left in solution just to guarantee all the free nitrates were used. And that little bit, I'm just going to toss that right into the anode basket on the silver cell at the end. The teeny little bit of extra impurities that's in these few pieces will not mess with our solution at all. So that little bit can go right in the basket. Minor technical difficulty there. We're back in action. Dilute our solution just a bit more. Nice. I guess I'm getting tired. Speaking of which, let's see here. It has been... what time is it here? Alright, well, it's been 10 hours today we've been going at it. So it was actually about 8 hours of digestion time. Yesterday, no, I didn't write it down. I don't know, but it didn't take an incredible amount of time, more than it would have normally if this was just like, if this was shot. It definitely took longer. I don't think it took more nitric acid. We had 400 units today. 7 yesterday. So we did it in just about 1100 mLs, which was pretty good. That's pretty good. Slow, but we didn't waste a lot of acid. I was worried about that. I didn't think it would have to work harder. You know, it would take longer. It had less surface base to attack, but the chemical exchange rate was the same. Alright, yep, I'm getting tired. So we'll follow up with this tomorrow, and we will precipitate our silver out of solution with copper, and we'll filter and dry that cement silver that we pull out of solution, and turn that into shot. From there we'll turn the shot into crystal via electrolytic silver cell. Alright, that's all from me for right now. Maybe we'll split this video into 2 parts. It's probably a good idea. It's already getting kind of long, so this will be part 1, and part 2 will be posted shortly. I hope you go to it. See you there.